Hi, this is Kaylee, and we're going to do a lens lab. So here's the basic setup. I've got my screen right there. The track has centimeter measurements already on it. There is our object, which is an arrow pointing up. And if I use the meter stick, we should be able to measure the height of that arrow. If I put it right about there, you can see what that is. Now that is the object. And so that will stay the same, but will vary depending on which lens I happen to be using and where the image shows up. So we're going to start off with this one. I'm going to clamp it down in there. Now you can see we got absolutely nothing. So if I move the lens out towards the screen, we eventually get an image, if you can see it, that's really, really small. That's no good. And if we move towards the object, you get eventually an image that is actually too big for the screen. I want to try to get that entire arrow on the screen. So I'm going to move this back out and move the screen in. And as I do that, I should be able to get an image that is on the screen right there, as sharp as we can get it, of our object. Now if I can hold this and get the meter stick in there, we can hopefully measure the size of that image. Okay, or as near as we can come to with this setup. So take a look at that. That's the size of our image. Now all distances are measured from the lens. So I'll put the object at 0 centimeters. The lens is at that measurement. And the screen is at this one. So knowing DO, which is distance to the object, and DI, which is the distance from the lens to the screen, you should be able to calculate the focal length of that lens. And then use that to double check on what the size of the image should be compared to what you measured it to be. Also notice that on here, on the object, the arrow is pointing up, but on here, on the image, the arrow is pointing down. So it also gives you an idea, not only that showing up on the screen, but the orientation, what type of image it is. Let's change out this lens for a separate one. So placing it there, we've got nothing. So I want to move the screen out a little bit. Maybe the lens out. Let's go this direction, towards it. We get nothing. Oh, nothing at all, so we're going to have to move back this way. Maybe move the screen as well. You know, we look like we're getting a sharper image. And it's a little bit sharper. It's about right there. That's pretty good. So, again, I'll take the meter stick, hold it up so that you can try to measure the height of that image as best you can. I put it this way, maybe it'll be a little bit better. Okay. Now, that screen is here. The lens is here, and again, the object is at 0. So remember, DO is from the lens to the screen, or sorry, DO is from the lens to the object. If we can focus. There we go. Object at 0. Lens is there. DI is from the lens to the screen, and the screen is on that measurement right there. Let's treat out one more lens. If we put it there, we're not too far off. So let me just move the screen here and pull it in. We don't really see anything changing much, so I'm going to move the lens. Move the lens this way. Oh, nothing's happening. Go here. Pull that lens, that screen back out. So we get a sharp image right there. That's pretty good. So again, let's try to measure the height of the image. And let's get the locations of our elements here. So the object's still at 0. The lens is at a position of that. And the screen is at this position. Again, determining DO and DI, you should be able to find the focal length of this lens. And knowing that, you should be able to estimate the size of that image, compare it to what you measured, to see how close it comes. Now here's a question. What if I cover the lens with this paper? What happens to the image on the screen? So what would happen if I covered this lens with the paper? Did you see the shadow of the paper come across? Or did the image fade? Think about your lens drawings and see if you can come up with an answer about why that happened like that. Thank you, and tune in for some more labs and more physics. Thank you. Goodbye.